In this lesson, we will talk about ammunition, how it gets fired from a weapon, and then the different parts that you can take a look at as a ballistic analyst to identify whether or not that particular ammunition has been fired from a certain gun. So to start off, here's the basic parts of ammunition right here. Okay, you have your cartridge case, which is the gold right here. The cartridge case holds the bullet, and it has the powder in it and the primer, kind of everything attached to it. So your cartridge case is right here. Okay, in this case it's a brass cartridge case. And then you have your primer. The primer is at the opposite end of the bullet on the cartridge case. And the primer, when struck by your hammer or your firing pin, is what sparks and ignites the powder that's found inside of your cartridge case. You have your propellant, and right here is all of your propellant. It's a smokeless powder these days. It's a mixture of nitrocellulose and nitroglycerin. And that is what ignites and creates kind of the explosion that's going to send your bullet out of the gun. And then at the very end of your cartridge case, attached to your cartridge case, is your projectile, which is your bullet that's going to get, or whatever else you're using, that's going to get propelled out of the barrel of the gun. So those are kind of the parts of the ammunition. Here's how it works. Here's kind of the process. The trigger of the gun is pulled. Okay, so somebody pulls the trigger. That sends the firing pin into the primer. The primer sparks, creates a spark, and that ignites all of this propellant that's in here. All the propellant burns very quickly, causing a huge formation of gas, which gas has to escape outwards. It creates an explosion, and the explosion is what propels the bullet down the barrel of the gun. And in your next activity, you'll watch kind of a short video of how this works, but that's kind of the gist. So the trigger of the gun is pulled, which sends the firing pin into the hammer. The primer sparks and ignites the powder. The powder burns, causing gas formation, which causes an explosion, and that explosion is what pushes the bullet out down the barrel of the gun. So here's just some different types of ammunition for different guns. This is ammunition that would go in a handgun. Okay, and you can see you've got your primer, you've got your powder, you've got your bullet. This is what it would look like before it was fired. This is what it looks like for a rifle. Again, same type of idea, right? You still have your primer, you've still got your powder. Notice that there is more powder. It's a longer cartridge case for rifles because they're a little bit more powerful. And you usually have a smaller bullet, okay, attached here. And then this is what a shotgun shell looks like. In the last talk, we talked that shotgun shells, or shotgun shells, which are a different type of ammunition, they still have the cartridge case right here, and they still have a primer, and they still have powder, but then they have what's called a wad. This is like a plastic piece, and then in here are all these little pellets, and then they're crimped up here at the top. And so what happens is when the explosion happens, this wad piece pushes all these pellets down the barrel of the gun, and that's how they spread out. So those are just some examples of different ammunition for different gun types. So let's take a look first at the bullets, and then we'll take a look at the cartridges. So bullets vary based on three things: size, shape, and composition. So there's tons of varieties of bullets that you can have, that you have the option for using. The first thing that can be different about a bullet is its size. Okay, we measure bullets in caliber, okay, which we talked about before. So it's the diameter of the bullet across the bottom. It's usually expressed in inches. So like you can have a 22 caliber bullet. It means it would measure 22 hundredths of an inch across the top. You could have a 45 caliber bullet, that's 45 hundredths of an inch, so on and so forth. So bullet size measured in caliber, expressed in inches. The second way a bullet can vary is the shape of the bullet. You can either have a round nose, a hollow point, or what's called a wad cut. And here are some better examples of those. So for bullet shape, you've got round nose, okay, which is the tip right here. Okay, It creates maximum penetration. It's the cheapest to manufacture. The second type of shape that a bullet can have is what's called a hollow point. A hollow point, it looks like this at the top. It's got like a cutout right here. And the purpose of this is so that it spreads or mushrooms on impact. It causes additional damage to the target, then more additional damage than what a round nose would. And it inhibits penetration. So it's not going to go through necessarily, but it's going to kind of attach itself. And so you can see here a hollow point kind of has the middle part hollowed out. And then a wad cut has got a flat surface here. This is used exclusively for practice loads. Its purpose is to rip a big hole in your paper so you can see where you're hitting at your target. So you've got round nose, hollow point, and wad cut are your 3 bullet shapes that you can have. And then for bullet composition, so what the bullet is made of, you've got 3 options kind of as well. You can have just a plain lead bullet. Okay, it'll look like this. These are cheap, they're dense, soft, easy to mold. Okay, so this is kind of the cheapest version that you can get. You can have a half jacket. And a half jacket is where it's a lead bullet and then it's coated halfway up the top with copper. Usually a half jacket is for a hollow point because it allows for mushrooming, and this right here is what we mean by mushrooming. When it hits its target, it mushrooms outward. The lead mushrooms kind of out and over top of the copper. So it's a lead bullet that's coated with copper halfway up. The copper improves exit velocity, it allows for mushrooming, etc. Or you can have what's called a full jacket. And a full jacket is a lead bullet that's completely coated in copper. It's used to hold the shape for maximum penetration. So these will kind of go the furthest in, and then this is what a full jacket looks like. So it's just basically, it kind of looks like a copper bullet, but it's usually a lead bullet that's coated in copper on the outside. So the 3 basic bullet compositions are lead, half jacket, and full jacket. So let's take a look if we're going to compare class characteristics and individual characteristics on both bullets and cartridges. Okay, remember class characteristics are going to be characteristics that can put the bullet or cartridge into a group of items. So not an individual, but a class characteristic. On the bullet, here are your class characteristics you can use to start narrowing down maybe what type of weapon you were looking for, etc. The caliber of the bullet, the weight of the bullet, and you measure weight in grains. The bullet type, is it a lead, half jacket, full jacket, and then the lands and grooves. And we talked a little bit about lands and grooves the other day when we were talking about our vocabulary. But lands and grooves will give you the manufacturer and the gun type. So different manufacturers have, 6 lands and grooves and they twist to the right, or 7 lands and grooves and they twist to the left. So in this case, when you're looking here at this picture, let's see if maybe we can make this a little bit bigger here so you can see it better. In this picture here, okay, the grooves are the big spaces in between, and the lands are these indented lines right here. Okay, and so you would count them. So 1, 2, 3, 4, 5, okay, and you would keep going all the way around. And then you can also see that they kind of slightly twist, in this case, to the right. Okay, if they were going the other direction, they would twist to the left. So you would count the number of lands and grooves. Those are a class characteristic on a bullet. That'll give you a manufacturer. On cartridge cases, there are 2 class characteristics. The head stamp, okay, and the head stamp is kind of the letters that are on here. Like this one says like Remington, UMC, and then it'll usually tell you the caliber down here. Like this is a 38. And so whatever is on the head stamp is a class characteristic. All the cartridge cases will look the same for that manufacturer and that caliber. And then whether or not the gun was a rim fire or a center fire will show up on the cartridge case as well. So a rim fire is where the firing pin hits on the outside rim of the cartridge case. A center fire is where the firing pin hits in the middle of the cartridge case. Again, these are class characteristics, right? Because it's going to put you in a group of category, but still important when you're narrowing down what weapon type you're looking for. For individual characteristics on a bullet, there's only one way to individualize a bullet, and that's with the striae. The striae are the parallel sets of scratches that are left on the bullet because of the rifling on the inside of the barrel of the gun. So when you're looking here, you can see the lands and grooves, but these little, underneath the microscope, these small scratches, okay, and you can see right here, those are the striae, and when you match them up, every single gun has its own unique striae that are unique to that particular gun only. So if a bullet is fired from gun A, it's going to have only striae that match for gun A. Gun B would have different set of striae. They won't be in exactly the same locations. So you use what's called a comparison microscope right here, and you would put like your crime scene bullet here, and then you would put your test fired bullet from the gun you think it matches here. And if you can get the striae to match up, so you can see that like these lines are in exactly the same locations and the same sizes, then you can say you individualize that bullet back to that particular gun. For bullets, the only thing that you can use to individualize is striae. However, for cartridge cases, there's several ways that you can individualize. Because the cartridge case has kind of more contact with different areas of the gun, it has a greater chance of getting marks on it. So one of the ways you can individualize a cartridge case is to use the firing pin mark. So notice these are three separate guns. In this one, the firing pin kind of had a squarish shape. This one, it looks more triangular. And then this one is circular and it's way off to the center. So the different locations and the different shapes of the firing pin as it hits the cartridge case. Extractor marks are another one. Extractor marks are usually found on the bottom lip of the cartridge case, and they're easily like indentations that are kind of out of the cartridge case. Ejector marks are found when it gets ejected kind of out of the gun, and they're found on the top. And if you notice here, this was the same, all 5 of these were fired from the same gun, and the ejector marks are right here on each one, circled in red. Breech marks are when the cartridge case gets slammed back in the chamber of the gun, and they're either parallel lines like this or circular lines around the firing pin usually is what you're looking for. And you can see this one went this direction. Those are unique to each gun. And then the last thing that you can take a look at for individual characteristics are chamber marks, and here's what chamber marks look like. Sometimes they can be parallel, sometimes they can be up and down, but they're marks left on the kind of outside part of the cartridge case from the chamber of the gun. So taking a look at a cartridge case, you can analyze any of these, and you can individualize a cartridge case back to a specific gun using a test fire shot, because the cartridge case found at your crime scene and the cartridge case from your test fire will have the exact same firing pin marks, extractor marks, ejector marks, etc. So these are all the individual characteristics that you could use when you were comparing a cartridge case to a test fire.